Okay, this video covers the 2019 AP Calculus AB free response. This is not a practice exam. This is the actual exam that was given in May of 2019. And I'm going to work through some of parts one and question one and question two, but there's quite a few of these that will not be on the 2020 test. So I'm just going to run through the parts that I think are could possibly be on the 2020 test. I'll go over, and the parts that I don't think will be on there, I'll just explain really quick why I don't think they'll be on there. So if you read through number one, it says fish enter a lake modeled by the function e of t, and fish leave a lake modeled by the function L of t, measured in fish per hour. Part A says how many fish enter the lake over a 5-hour period, and give the answer to the nearest whole number. This is a question that will not be on the 2020 test if they told the truth. But how you would figure that out, it's really not hard at all. You would integrate from 0 to 5 of e of t dt. And you would use your calculator on this. But this kind of problem is not on the 2020 test. Okay, any problem where you have entering and leaving and you're accumulating something, then that is not supposed to be on the test. Okay, but part B might be on there. It says, what's the average number of fish that leave the lake? You do need to know how to calculate an average. All right, now this type of function I don't think will be on the 2020 test, because if you had to do it by hand, that's logarithmic differentiation. And I don't think they'll give you one like that. However, they could give you a function that you would have to do by hand. So the average is going to be 1 over b minus a, so that'd be 5 minus 0 of L of t dt. So they would give you a function that you could integrate by hand, and then, sorry, the limits of integration are 0 to 5 on that one. It's about 6.059 is the answer. Again, you would get one that would be easier to do by hand, but you do need to remember how to get an average using integration. Okay, part C, I don't think you'll see one like this, but I'll go ahead and talk through it real quick. It says, at what time is the greatest number of fish in the lake? Well, the greatest number of fish in the lake is going to be, you're going to take the entering, e of t, and then subtract out the leaving, and set that equal to 0. So as long as e of t, the entering, is greater than L of t, then the number of fish in the lake is going to be increasing. Okay, so you would put this one in your TI-89 calculator and solve for t, which is 6.2. So if you had to do one like that, it'd be one you could do by hand or with a very simple calculator. So as long as t is between 0 and 6.2, then it's increasing. And you could also, of course, graph that on your calculator, you know, if this were a normal year. But it is possible you could be given one like C, where you had to, as long as the equation was simple and you could do it by hand, that where you would have to solve for t in a situation like that. And then part D says, is the rate of change in number of fish in a lake increasing or decreasing at t equals 5? So what you would have to do there is figure out e prime of 5. So you would take the derivative, because that's rate of change, right? Take the derivative of e and subtract out L prime of 5, because that's a rate of change that they are leaving and see what that is. Now, if you had got to use the fancy calculator, you would do that, and you would let the calculator do all the work for you. But it would be an easier function to take the derivative of. But one like this would be fair game. It's just going to be an easier function to do by hand. But you'd get minus 10.7. So that means the rate of change, if it's negative, then it would be decreasing. Okay, so the rate of change in number of fish is decreasing since E prime of 5 is less than L prime of 5. So again, that would be fair game on the 2020 test. They're just going to be giving you easier functions to deal with if they gave you one like that. Okay, so that's a quick run through on number 1. The most important part on this one, I think, is B. You got to know how to take an average. Okay, let's take a quick look at number 2. I do think a couple of parts on number 2 is fair game. So number 2, you are given, and I'm not going to write the table in, but you're given a table. And it's a velocity function that we're given here. And part A says, justify why there must be at least one time t at which v prime of t, the acceleration, equals 0. So I'm going to draw a little graph of this, but you can see the velocity goes from 0 to 55. And then it goes from 55 to negative 29. And then it goes back up to 55 again. Okay, so let's just do just a quick graph of that, just by hand. Okay, you've got velocity, you got time and velocity. So we've got 0 and 0 at time 0. At time 0.3, it's at 55. Let me get this out of the way here. We'll put time over here. All right. At time, so that's 0.3. At 1.7, it goes negative 29. And then at 2.8, it's back up to 55 again. Okay, so, right, you're going something like that, right? So, we don't know if the graph looks exactly like this, but we do know that somewhere along the way, if it's going to go positive to positive again, there has to be a tangent line slope must equal 0 at some point between t equals 0.3 and t equals 2.8. Okay, so it's got to be somewhere in between the two because it went from positive to negative back to positive again. So what they're looking for here, if you have to justify or explain what you want to do, you know that the slope of the secant line between 0.3 and 2.8, that slope has to be 0 because you go from the same number to the same number of again. Okay, the secant slope is equal to the change in y over the change in x, right? So that's 55 minus 55 over 2.8 minus 0.3. So that's just going to be 0. So your justification would be the mean value theorem states that at some point the slope of the secant line must equal the slope of the tangent line. So v prime of t is equal to 0. All right, somewhere between 0.3 and 2.8. So you could just write, I'm sorry if you can't read this, somewhere in interval. The main thing you want to get in this problem is maybe draw a little graph to help them see what you're doing, get the secant slope, and then mention the mean value theorem. Okay, if you can do that, then that should be enough to get credit on part 2A. Okay, I'm going to erase all this. Okay, part B says use a trapezoidal sum. So I'm glad this problem came up because usually we're doing Riemann sum with rectangles, right? And I expect Riemann sum, if you're going to get one of those, that's what's going to be on the 2020 test. But who knows, you know, maybe they'll throw you a trapezoidal sum. Maybe they're not feeling very generous. But trapezoidal sum is not much harder than a Riemann sum. So if we look, and it just wants us to use these first 3 intervals. Okay, so using a trapezoidal sum from 0 to 2.8, so we don't even have to use that final interval there. Okay, let's see, Vp of t, dt, it's going to be the base times the average height. So it's just the sum of the bases times the average height of each interval. Okay, so our first base is going to be 0 to 0.3, so 0.3. Our average height would be 55 on our first one minus 0 over 2. Our second base goes from 1.7 to 0.3, so that's, I'll go ahead and write it like that, 1.7 minus 0.3. And then that's going to be 55 plus negative 29 over 2. That's your average second height, second trapezoid. And then 2.8 minus 1.7, and you would get to use a calculator on this, but they'll probably give you easier numbers. And then another negative 29 plus 55 over 2. So if you'll put all that in your baby calculator, or your fancy one if you prefer, you should get 40.75. So give that a try, make sure that works out. So that's great. I think parts A and parts B would be fair game. C and D, no, and let me tell you why. So C and D are probably not on 2020 test because they involve integration. You should not have to do integration unless it's an average. You should not have to do integration on a position, velocity, acceleration problem. You should only have to do, unless it's this kind of thing where you're doing Riemann sums or trapezoidal sums, or you're doing a mean value theorem kind of thing. Let's see if you understand that, like we did in A and B. You should not have to integrate. So you shouldn't have to get a total distance, right? That would be integrating. or find the position. You shouldn't see that on the 2020 test, but you could see a position, velocity, acceleration problem, but they would give you position, you would have to find velocity, or give you velocity, you'd have to find acceleration, take a derivative. All right, that is parts of 1 and 2. This is the actual test. We had at CCA one student make a 5, one student make a 3 on this, so it was a doable test. And so I will continue on with the 2019 on the next video.